We heard the word polygon before?
Oh, I can do this.
Okay.
I did this with one yesterday.
Okay, so a polygon has to have a finite number of segments called the sides. So it's the opposite of infinite. We've heard of infinite or infinity.
It's a number that is like a definite number.
Right, so you know the infinity symbol? Like that? It just represents a really, really big number that we can never count to, right? But finite means it has an actual number. So you can have a polygon with 5 sides. You can have a polygon with 10 sides. You can have a polygon with 100 sides, right? You can even have a polygon that has 1,000,000 sides. But it has to have an actual number. Okay?
It's not never.
What's that?
It's not never.
Right. So we have sides and we have vertices, right? A vertex at each point. The plural for vertex is just vertices, right? So, okay, here are some examples. Oops, that was too big. So let's look at examples of polygons. Notice these all have straight edges. Okay, we can count the number of sides. This one's kind of funny shape, but that's okay. It still has all straight lines, right? Triangles. This looks like a trapezoid. These are examples that are not polygons. What do you notice with the ones that are not polygons, Mia?
They're curved.
Right.
Lines are diagonal.
Good. So we can't have any curves.
And
right?
also one of them doesn't connect, but that one's also diagonal.
Right. This one, these crisscross. Can't have that. You can't have it not closed. And this side, if we didn't have this little line segment, that would be a polygon. Sienna. So, right, but because the side keeps going, then it doesn't count as a polygon, right? And we can't have ovals or circles. Okay, have we heard the terms convex and concave before?
No.
In mirrors? Okay, so if you have a concave mirror, this is an example of a concave polygon.
Inverted.
It goes inward at some point. Versus all of these are, this one here, you see how it goes inward? That's a,
What do you mean? It's an acute.
how do we know concave versus convex? Basically, if we extend the sides, like if I were to extend all the sides of this polygon, notice it doesn't cut through the polygon, versus if I extend all the sides of this polygon, you see how the sides start going inside of the polygon? That's how you know it's concave.
Only one side goes.
Whoa.
That's okay. All it takes is one. Here's an example. See? When we extend these sides, I kind of think of concave like it caves in, right? Cave in, concave. Okay, naming polygons. We need to memorize the ones that are on here. Some of them hopefully are already familiar. 3 sides, triangle.
For the
Right.
definition to just write the whole
Yeah, I would just make triangle 3 sides. Quadrilateral.
So we need to find for all of them. No, we chose like one that.
You could do one that has all of them, or you could do them all separate. Okay, quadrilateral. Now, 4-sided polygons. Well, we know like a rectangle and a square. Those are 4 sides, but we want to think very general terms. So that's why we call them quadrilateral. Okay. Pentagon has how many sides? 5 sides. Hexagon has 6 sides. Okay, now it starts getting probably into some unfamiliar terms. 7 sides is a heptagon.
Oh my god.
I know octagon.
Octagon, like a stop sign, is an octagon. 9 sides, nonagon. So 10 sides, decagon, maybe we've heard of.
Okay, you need to teach us how to pronounce this one.
And then 12 sides, dodecagon. Now, anything beyond 12, and also for 11 sides, so let's say we have a 20-sided polygon,
And gone.
we just call it 20-sided polygon. We don't actually say gon.
20 gone?
Wait, why is it? Why
We
is
just write it out that way.
Okay.
20 why does it skip 11?
We don't need to know 11. It's not one of those that we encounter often.
Oh, wait, it skips 11.
Yeah, it skips
Tell us
11.
what 11 is, though.
I don't know off the top of my head.
Oh, actually? I thought you were a math teacher.
It's irrelevant.
It's irrelevant. Okay, we got some
No, decagon.
equilateral polygon. Okay, if we look at the first part of the word, we think of equal. Lateral,
All sides are.
lateral is referring to the sides.
Wait, does that say 20 slash? Wait, what is
Yeah.
It's like a polygon.
It's just a polygon with more sides than 12. Okay, equilateral is when all the sides are congruent. So here's an example. Okay. This is called a rhombus. We don't need to worry about that term yet because 1, 2, 3, 4 sides are all congruent. Yeah, yeah.
So if it has like lines in all the sides, that means it's congruent, right? That's how we-
That's correct. So if we see these little tick marks in 4 of the sides, we know that that's referring to all the sides are congruent.
When are we going to start
Okay.
having worksheets?
All right, equiangular polygon. Look at the term equiangular. So this is referring to the angles. So this is when all the interior angles are congruent. So take a look. What kind of shape is this? It's a rectangle. What do we know about a rectangle?
There's 4 right angles. And
All 4 angles
congruent from each
are
other.
congruent. Okay.
How do you even say that?
Equiangular. You have to kind of split it up. Equiangular. So don't try to say it all at once. Think the first part of the word is equiangular. Equilateral. Okay. All right. What if we combined equilateral and equiangular into one?
A regular.
That's a regular polygon.
Well, because
Why did both of the hard things like
What's that?
both the hard names equal, it's just simple names.
I know, a regular polygon. So this is a convex polygon that's both equilateral and equiangular.
Convex means the
So a
opposite
square.
of concave, so they don't.
It doesn't cave in, right? So here's our example,
The cards.
and this one is a square,
I love squares.
right?
Oh, it's always a square, a regular
Well,
polygon.
it can be a different shape. These are just examples, okay? So this is our one example.
Rhombus equaling.
So a rhombus is this one.
Oh, okay.
This is a rectangle. And if you made a shape that was both a rhombus and a rectangle, so you get yourself a regular polygon. So are all the sides congruent?
That's a square.
Yeah, so this also qualifies as a rhombus. So this is equilateral and it's equiangular. And so when we combine that, we get a regular polygon. Yeah, Mia.
Why on the equal angular one, only one side of the rectangle has no line, but like both those sides are.
Oh, there should be one. I don't know why it didn't show up. No, it's the only type of regular quadrilateral. Can you have a regular triangle? Yes. So if I were to make a triangle and I put all the sides congruent and all the angles congruent, that would be a regular triangle.
That'd be equiangular.
It's
What is convex?
we talked about that on this page. None,
Stop messing up my binder.
when we extend the lines, it doesn't go inward at all. Okay.
Okay, so this one is.
Okay, so hold on. Let's go through. First, we want to name the polygon by its number of sides. So let's see.
That's
1,
decagon.
2, 3, 4, 5, 6, 7, 8, 9, 10.
I just said that.
And they're all congruent.
Okay, so decagon. So we'll name it first. Next, we want to name it, is it convex or is it concave? Does it cave in? It's concave, so good.
so funny.
Like, 'cause if they all go in, they all cross.
That's concave. Now, is this regular or irregular? Well,
Irregular.
it's irregular because first of all, look at the regular polygon definition. It has to be convex.
Kids, I've never had to go with you.
So it's, oops, I meant to say irregular there.
Wait, you just write irregular, regular?
So there's 3 questions. Naming the polygon, then we're gonna write if it's convex or concave. We said it was concave. And then regular, irregular. But back here, the definition of regular has to be convex. So the fact that it's concave, it will always be irregular.
Okay, sis, on the test, are you gonna give us a little chart? Or we're gonna remember all of this?
No, you have to remember those. Okay.
Okay, this one is a hexagon because it looks like a
Okay, it's a hexagon because it has how many sides?
It
Good.
looks like a stop sign, right? Isn't that how you spell
Yeah,
Octagon
well
is.
done.
it? Oh, I'm taking my permit test.
Okay, is this convex or concave?
It's concave.
Context, because it doesn't go with.
It doesn't go,
It doesn't.
it
Oh,
doesn't.
No, it doesn't. I lied.
That's okay. And is it regular or irregular? Are all the sides congruent?
Yeah.
And are all the angles congruent?
Yeah.
This is regular. Any questions on those 2?
Here's what I thought geometry would be like. Probably just like
Be like shapes.
yeah.
It's a lot of other things. Okay,
Oh no.
a quick review of perimeter, circumference, and area.
Oh, my favorite.
Okay, let's look at a triangle first. How do you find the perimeter of something? You add up all the sides. For perimeter, we're just adding the sides. So
on regular or irregular?
it was regular. So we add the sides, right?
So what should we make the flashcards with?
For, oh, my smiley faces went, that's okay. Hopefully we know some of these. I'm hoping some of this will look familiar. What's the area of a triangle? 1/2 base times height. What do we know about the base, oops, what do we know about the base and the height?
Can you just multiply
What,
base times height divided by 2?
One where the
it has to make a right angle, so we always have to make sure. Yeah.
Can you just do base times height divided by 2?
Sure.
yeah, that's how
I actually like that one too. Base times height divided by 2.
So do we put triangle area formula as the front?
Probably what I would do is do triangle and then put perimeter formula and then the area formula. Okay, square. What do we have to do? Just still add up all the sides, right? But what happens with the square? All the sides are the same. So you could also just do 4s. I don't care. They're the same thing
Oh, yeah.
because you have 4 sides. And then for the area, all you have to do is the side times the side, or do side squared. Now,
Wait, what? Just a second.
like if this was 5 and this was 5, you would do 5 times 5, right? Or 5 squared. But isn't a square a special kind of rectangle? So could you use the same formula as you do for a rectangle? Yeah. Adding all the sides are 2L plus 2W, or we could do 2B plus 2H if you want to do base times height.
Can we just make circle 1 plus then?
The area of a rectangle, length times width, or base times height, right? Same formula. And then circles. So we don't say the perimeter of a circle, we say circumference, right? Because perimeter is adding all the sides, but does a circle have sides to it? No. So that's why, hopefully this looks familiar, 2 pi r, or pi times d, where what's r represent?
Radius.
The radius, and d is diameter. And then area formula, pi r squared.
How do we do pi r squared?
It's like
Do r squared and then multiply by 3.
Right, so think order of operations,
diameter
right?
split
What do we want to
half.
take care of first? We're going to do r squared, and then multiply it times pi.
Yeah, but we just put
Just
3.14.
Oh, I remember
Should
this.
I'm sorry, what?
I take my pictures? I have to go for next one.
Oh, okay.
Go now, Mia. Just a volleyball game today.
We have practice.
This won't take us too long if you want. I mean, I'm also recording, so you could always watch the
I
second
know
part.
myself. I'm fine.
Okay, let's, this won't take very long. We want to find the perimeter, and then we're going to find the area. For this circle, we're going to do the circumference. Okay, we have a question though. How do we find that third side? Yeah, I mean,
Don't you do? Yeah.
that's what you're going to say?
I was gonna say the Pythagorean theorem.
That's right, Pythagorean theorem. So 6 squared plus 8 squared equals c squared. Okay. Remember that a squared plus b squared equals c squared?
And that's
36.
plus 64.
Oh, that's 100. So that makes it easier.
And then
We take the square root.
yeah, and then you square root that, but that's on.
What's the square root of 100?
Square.
It
Oh
is.
yeah, it is 10.
It's 10. It would be plus or minus 10, but because it's a length of a segment, it's always, we're just going to make it positive. Okay, perimeter. How do we find the perimeter again?
6 plus 10 plus 8.
Good, adding up all the sides. So 6 plus 8 plus 10 is?
Oh, 16,
24.
24, good.
That's a lucky number.
So 24 feet. Okay, area. We want to do base times height divided by 2. Which two sides do we have to use for the base and the height?
The 6 and 8.
6 and 8 because they make a right angle. So 6 times 8.
Wow, it's just my lucky day.
Now, for area, what do we want to do with the units? Square it. Okay, good.
And then this one is
Okay, so this one has a circumference, pi times diameter.
yeah.
So we can just leave it as 6.2 pi centimeters, or on your calculator,
Don't you do radius squared? We use that calculator for the test.
yeah, the test will actually be calculator. Okay. Right down here, just the second or third one from the bottom, if you see there's like a little pi symbol, and it will highlight. So there's lots of different options, but we just want to use the pi button. So this would be about 19.5.
We don't have to break that.
No, so listen,
Do we have to do that about?
so
Or if we do 9.5?
I'm okay if you leave it in an exact form, like for right now. Sometimes I'll say leave it with pi in your answer, and sometimes I want you to put it in your calculator and round.
Will you say?
Yeah, I'll specify.
Do we have to do like the about?
No, that's okay. Let's do the next one. What's the rate? We need to do area.
6.2, you have to divide it by 2.
Good, so that's going to be 3.1. So if I just do 3.1 squared, I get 9.61. Oh, I almost forgot my pi. There we go. So here's circumference, here's the area.
Can you multiply that?
You can multiply it out too.
Why didn't you circle that whole?
Oh, it's just, this is an approximate. I'm fine if you leave it in an exact. Okay, last two. Length of a rectangle is twice the width. Okay, let's draw a picture. Okay, if I want to make the length twice the width, so let's say I make the width x, what would I make this side? The length. What's it say? The length of
Or 2x.
2x. Does that make sense? So this is the width, and the length is twice that. The area is 50 square meters. Find the perimeter. Okay, what's the area formula for a rectangle? Base times height. So we know the area
Divided by 2.
for a triangle. This is for a rectangle. What's, right? The area is 50 square meters. So I'm going to replace A with 50. What's the base?
2x.
Times the height.
Can you just do 2x squared?
Good. So that's going to be 2x squared. Okay. Okay, how do we solve that?
You square the,
Let's divide by 2 first.
oh, right.
Yeah, always divide first. We want to isolate.
25.
25 equals x squared, and then you're gonna find.
And then we take the square root,
And you get 5.
and we get 5. Now, what's the perimeter then?
So then you add up the side.
Okay, so if x is 5, and that would make,
30.
right, so it's going to be 2 times 5 plus 2 times 10.
Wait, why'd you put 5 and 10 there?
Radius and diameter.
So I plugged it back in. This will be 5.
Oh, right.
This will be 10. And then, right, we have this.
Why 10?
So we have 2 5s
Oh, it's 2
and 2 times, yeah. So 10 plus 20,
So p equals 30.
good. And that's going to be meters. Okay, last one. Area of a circle is 64 pi. What's area formula again?
Pi r squared.
Good. Pi r squared. So what is the area equal to?
So you have to divide 64 by 2.
64 pi. No, first we want to isolate. Remember how we isolate? We divided both sides by 2 here to get x squared by itself.
And then you divide it
So
by
I want to
5.
divide both sides by pi. Good. And then we get 64.
Is pi actually
Wait, is
infinite?
radius and diameter the same?
Radius is half the diameter.
And then you get 8 equals radius.
Okay. So now I want to find the circumference. What's the circumference?
2 pi r.
2 pi r. So we get 2 times pi. What did we get for the radius? 8. So what do we get for our answer? Just multiply the 2 and the 8.
16 pi.
16 pi. And that's just going to be inches.